understand how REST works. How REST works. Okay, you all understand, right? Your HTTP protocol, this .1. So currently, as part of REST, you are using your HTTP 1.0 protocol. This is HTTP 1.0. Okay, and then this HTTP 1.0 has certain problems. So first of all, to understand those problems, understand how your HTTP protocol works, or let's say, I would say, how HTTP protocol works. Okay, so you all understand your HTTP is a layer in your networking layer. You have an OSI model, right? So there are certain layers, right? So your HTTP is your layer 7 protocol, correct? And then here comes your TCP, which is your layer 4 protocol. So your HTTP works on transmission control protocol. It works on transmission control protocol. So in order to understand HTTP, you need to understand how TCP works. So first we were discussing about how REST works. Then we came into how HTTP works. Now we will be discussing about how TCP works. Because the answer of how TCP works will also give you the clarity of how HTTP works, and eventually it will also give you the clarity of how REST works. Okay, so let's move on and understand how TCP works. Okay, TCP working. So you have your client here, and then you have your server here. All right. So first, for each HTTP call, so let's say you are trying to perform a HTTP call to this from this client to this server, right? So it will so there is a TCP handshake happens, right? So what this client will do, it will send, let's say, a synchronization segment, a TCP segment to your server and saying, hey, I am requesting a connection. Okay, server, if server is up and running, server will simply acknowledge this thing. It will say, okay, I'm comfortably okay, just move on, just go ahead. Then it first requested, and then this guy received it. All right, now this guy will send, okay, establish connection, and then this guy will say yes. So this was the part of your establishment. So now your network is connected. You are connected now, right? Now this is your TCP connection made. So now you have one service. Let's say this is your service 1. Now let's say this is your service 1 and this is your service 2. Okay, now you have this order service. So this is your order service. Okay, and then let's say this is your invoice service. It's not like that we are discussing about it's not like that we are discussing about a network, right? It's more of, if you see, it's more of whatever we are discussing, more of a part of a distributed system. Okay, so this is your order service and this is your invoice service. Now order service wants to call an API of your invoice service. So in this particular case, your invoice service will be the server and your order service will be acting as a client here, right? Now the API that the invoice service has is kind of a REST API. Okay, so when I say REST API, that means there will be a HTTP call from your client order service to invoice service. When I say order service to invoice service, can I say that, okay, from your client to server? So before making a HTTP call, if you let's say have implemented your application Spring Boot, right? You must be using a server. Then it will try to create a connection between here to here. So before making a HTTP call, there is a TCP connection has been made between order service and the invoice service. Okay, now once you are done with that, then this client and here server, it will start the data transfer, right? So your connection, TCP connection is bit. That's the point number 1. That's the point number 2. Now you will start transferring your data. Okay, when I say start transferring your data, what does it mean? It means, because if you're calling an API of server, you must be passing some kind of JSON data, right? Because let's say you are calling an API to get me invoice, but in order to get the invoice, you must be passing some ID, so that your invoice server will go to the database and try fetching out some kind of your data invoices from the database and will send it back to your order service, which is your client. So this is a order service, okay, and then this is a invoice service. Okay, so now your data transfer, when I say data transfer, this is HTTP call, so this is your REST call, so you are sending a JSON data, right? JSON data, and then and what is the JSON data? You must be sending some kind of IDs, let's say ID 1, 2, 3, etc. And then this guy, so this is your response, this is your request, and then this is your response. So in the response, you are getting a JSON response, right? JSON response. So let's say your invoice ID, etc, etc. All right, so that's how your HTTP works. Okay, now let's understand, do you know even that your applications indirectly are maintaining your TCP connection? Let's try to understand this from the Spring Boot perspective. If you are a person of Java in Spring, right, you might have heard of Spring Boot, or let's say any application that in which you are creating the REST applications, deploying it on a container, and you are trying to deploy those services in terms of client and server model. You must be maintaining some sort of TCP connection in order to call the other APIs, the other services. All right, so now specifically let's talk about Spring Boot. So let's say this is your order service. Okay, now this particular order service, I'm making a broader picture of your order service. Okay, now here let's say this is another service. Now this guy, you have your controller, you have services, so internal of your TCP, so this guy will be making a lot of connections to your invoice service, right? Actually, let's create another diagram. So this guy, which is your client, it will be making a lot of connections to your server, which is invoice service. Now for each HTTP call, how will it work? So for each HTTP call, now you want to call an API of get invoice, right? You want to call an API of, so this is get, or this is invoice, or you pass ID here. You want to call this API which belongs to this service, right? This belongs to this service. So before making an HTTP call, you will be this order service will create a TCP connection first. So it will create a TCP connection, TCP create. So this is one part, and then you will send HTTP, right? Your REST call, then you will get a response, then this TCP connection is free. So now this is your service, this is your, let's say, Spring Boot app. Now let's say, now this is only, this whatever I explained, this is only for one single HTTP call. Now there are multiple threads, there are multiple requests going from order service all the way to invoice service. So in that case, your service will not keep on creating connection, closing connection, creating connection, closing connection. Rather, it will create TCP connection pool, right? So whenever this client order service wants to make a HTTP call to your invoice service, so your service will go to the TCP connection pool. So here, somewhere here, you will have a TCP connection pool. So that's the basic connection mechanism, right, that anyone have as part of your services. So implementation of services. So this guy will be using a TCP connection pool. So if you want to call an API, it will go and see if you have a TCP connection available or not. If there is a TCP connection, it will create and it will use that connection and send your HTTP call. And if it's not available, then it will wait for some time unless that HTTP connection, TCP connection gets released, and then again it will pick up a new one and then send the HTTP call. So that's how your HTTP and everything works, right? So if I say, so if you see, if there are, let's say n is equal to 100 calls, right, then there will be 100 TCP connections you will have to make. Although you will be reusing it from the connection pool, right? But there will be 100 TCP connections to this guy. This is client and this is server, right? So for each one HTTP call is equal to one TCP connection. So you see, now this is the problem. What your application is doing, it's keep on connecting, using connections here and again, right? You are trying connecting TCP with the server again and again. You are using multiple connections. That's the performance. That's where your HTTP1 is taking a lot of time.